Welcome friends, welcome to my channel APS. This is the 5th episode of previous year's questions of JEE Mains and Advanced. Hope you like the video and don't forget to subscribe and click the bell icon for more updates. Thank you.
Hello everyone, APS here. So today we will discuss previous year's question based on the topic simple harmonic motion. So let us take the first question of JEE Mains 2015. So what does the question says? For a simple pendulum, a graph is plotted between its kinetic energy and potential energy against its displacement d. Right? Displacement, look at the word displacement. Remember, which one of the following represent this correctly? Which one of the following graph represent this statement correctly? Okay, so if this is a simple pendulum, okay, this is at its equilibrium position, then it's again moved to the right extreme up to this point, then again it will come back here, right? For it, this is equilibrium position, it goes there, then again it will come back here, then again it will goes there at right left extreme, then again it will come back here. So this is means first it starts from here, it goes there, then again here, then at left extreme, then again at equilibrium position. So this movement is called one time period. This movement is called one time period. This is called time period. Okay, so we have talked we just now talk about time period. So let us understand this. So we are drawing this like this. Let this be the left extreme, and this is the equilibrium position, and this is the right extreme. Okay, again let us draw. This is equilibrium position, means this position of the ball, this is equilibrium position, and this is the right extreme, and this is the left extreme. This means this point and this point. Okay, right? So when it will perform SHM, we know that when the displacement is increased, if the ball starts from here, it moves there. When the displacement is increased, then acceleration in the opposite direction will increased. Means if a ball starts SHM from here, it goes in this direction. So as the distance is increasing, the acceleration in the opposite direction increases, right? So at this position, when it will perform SHM at this position, that is equilibrium position, it has the maximum kinetic energy, and when it moves to the right extreme, its kinetic energy converts to its potential energy, right? Its kinetic energy converts to its potential energy, and at the right extreme corner it has the kinetic energy of 0 or minimum, and it has the maximum potential energy at right extreme, right? So it will first goes at the right extreme, then again come back to the equilibrium position, then again it will goes to the left extreme, and again it has the maximum potential energy and 0 kinetic energy at the left extreme. So what do we get here? That if this is the equilibrium position, then at equilibrium position the kinetic energy is maximum, right? And at the extreme, it has the maximum potential energy, right? So at the reference, if you take the reference as 0, then at origin, that is from where the ball starts moving, that is this point, it has a maximum kinetic energy. So let us see which graph match with our concepts, right? So if we take the first graph, what it says that this green color represents the kinetic energy graph, and this blue dotted lines represent the potential energy graph. So for potential energy graph, this is the, if we take this as a reference, so this is the origin, right? So at origin, we proved here, at origin kinetic energy is maximum. At origin this kinetic energy is maximum. So this graph little bit satisfied us, okay, right? And it says that at equilibrium potential energy is 0, right? At equilibrium potential energy is also 0. So this graph little bit satisfied us, and now we'll use elimination method, means which we do not find which option is not good, then we'll just eliminate that option, right? So in the next option it says that at origin it has the minimum kinetic energy, so this one does not work to our concept, works as according to our concepts. Then again at this option C, at point origin it has the minimum kinetic energy, so this will also be not there. But this graph, right, this option D, at origin it has the maximum kinetic energy, so this also satisfied, right? So we know that for we know the formula of potential energy, that is P equals half m omega square x square. That means that P is directly proportional to x square, right? P is directly proportional to x square. Okay, so it's that potential energy makes a graph of parabola. The potential energy makes a graph of parabola, but here the potential energy does not makes the graph of a parabola. This equation becomes a parabola, na? Y equal to ax square, right? Y equal to something, this a is a constant and x square. Okay, just trying to assume or try to realize this. Okay, so this makes a parabola because this equation, we know that this equation potential energy equals half m omega square x square. So potential energy is directly proportional to x square. So in this equation, this is from any angle, this does not seem to be a parabola, so this option will not work. And if you see this option, this is a parabola. Okay, so this condition satisfies, so this is our correct answer. Now let us take the next problem and try to discuss that. Okay, so if you would be able to understand the previous problem, then you can easily solve this problem, right? So what's the problem says? A particle executing SHM with a time period t, the time period is t, at time t equals 0 is at its position of equilibrium. Means at time t equals 0 it is in the position of equilibrium. The kinetic energy time graph of the particle, means kinetic energy time graph of the particle, we have to show which graph represents correctly, right? So in the previous problem we discussed that if this is the equilibrium position, then this is the right extreme and this is the left extreme, right? This is the right extreme and this is the left extreme points. So at equilibrium position, in the previous problem we have shown it has the maximum kinetic energy, right? So it has the maximum kinetic energy. And what is a time period? Means the particle starts moving from here, it goes to this, then again at this point, then again at this point, then it goes there. So this is t, this full is t. So if particle starts here and it reaches there, if a particle starts from a equilibrium position and it reach to right extreme, so what time it's required? It's need t by 4. The time required is t by 4, right? This full is t, this full is t, right? So this part will be t by 4. So at this point it has a maximum kinetic energy, and at t by 4 we proved in the previous problem that at right extreme it has the maximum potential energy. All kinetic energy converts to potential energy and kinetic energy is 0, right? So we can easily match the graph. This graph shows that at equilibrium position it has zero kinetic energy. This is totally wrong. And if you see this, then it's correct that at origin it has a maximum kinetic energy, but at t by 2, that means this time, if particle starts from here, then this is t by 4, then again this is t by 2. It's reach again like this. It reaches again equilibrium position, so it will have again 0. It will have again 0 kinetic energy, right? It will have again maximum kinetic energy. So this graph also does not satisfy it. But if you see in this graph, it starts from origin and it has the maximum, so this condition is satisfied, kinetic energy is maximum, and at t by 4, that means this point, this t by 4 point, it has the lowest kinetic energy or zero kinetic energy and maximum potential energy, because all the kinetic energy converts to potential energy when it's moved from equilibrium position to right extreme, right? So at t by 4 it has zero kinetic energy, so this option is correct and this is the correct answer. So this is the correct answer and we have done the problem. Thank you so much for watching the video. If you really like the video, then please do hit like, share and subscribe. Thank you.